we have looked at arrays and their utility. We have in particular looked at one dimensional array, and today we will introduce another variety of array which is two dimensional array. In fact, we can have multi-dimensional arrays in general. Arrays can be, we can have what is happening with this, n dimensional arrays. For a particular value of n equal to 1, we are having this one dimensional array, right, where I have got some say one dimensional array of integers. So, for n equal to 2, we can have two dimensional arrays, that means where there will be length and there will be a breadth of the array. So, that array can be considered of consisting of a number of one dimensional arrays. For example, as I am showing in this diagram, I have got two dimensions. On this dimension, I have got 4 rows and on this dimension, I am sorry, this let me draw it afresh. So, on this side I have got 4 rows and on this side I have got 1, 2, 3, 4, 5, 6 positions. So, these are called columns, these are called columns, and these are called rows, right. So, here I have got two dimensions, one is the length, that is 6 or 6 columns, and the breadth, which is 4 rows. Since there is two dimension, so it is a two dimensional array. Okay. So, a two dimensional array like this can be considered to be consisting of, say in this case, 4 one dimensional arrays arranged one after another. So, this is one array which we learnt till now. This is another array, this part is another array, this part is another array. So, we have got 4 different arrays, 1, 2, 3, 4, 4 different arrays arranged one after another. Okay. So, I can have for n equal to 2, I have got rows and columns. So, we get two dimensional arrays. Similarly, for n equal to 3, we can have 3 dimensional arrays. Like so, I have got one two dimensional array like this, and we can think of another two dimensional array lying here, another two dimensional array lying here. In that way, I can have an arrangement of say maybe 3 or 4 two dimensional arrays one after another. That is also an arrangement. Each of these may be 4 rows and 6 columns, sorry, maybe like this, 4 rows and 6 columns. So, this row, this 3 dimensional array will be 4 rows, 6 columns and 4 such 2 dimensional arrays. This is one 2 dimensional array, this is another 2 dimensional array, and this is one 2 dimensional array, and we have got 4 such 2 dimensional arrays arranged one after another, right. If I had one more here, if I had one more here, same array, then this would be changed to 5. Okay. In that way, I can extend my concept of arranging data as we had done for one dimensional array. We are extending it to 2 dimensions, 3 dimensions. In that way, it will be difficult to show it on the screen. We can go up to n. So, n dimensional arrays, okay, which will have different dimensions altogether. But today we will be just discussing about 2 dimensional arrays, and the thing is quite general and can be extended to other dimensional arrays also. So, we are now talking about 2 dimensional arrays. You can see the most common example of 2 dimensional array is a table. Table means an arrangement of data just like this. This arrangement of information is known as a table. Often we see table in other forms also. For example, I can have a table of something like this. So, the first here I put name of the boy, name of a student, then I stored age of a student, school to which the student goes, and address of the student may be, and I have got such scope of keeping it for say 4 students, 1, student number 1, student number 2, student number 3, student number 4, and I go on. So, this is known as a table, because I am organizing them in a tabular form. Okay. So, this is a table. So, what we were looking at now is another table, where here I am showing that there are 4 students, student 1, student 2, student 3, student 4. For each of the students have got some marks in the different subjects, subject 1, subject 2, subject 3, subject 4 and subject 5. So, I can consider that all the marks of student 1 in the different subjects are stored in a row, this row for the first student. Similarly, this row for the second student, right. Similarly, this row for the third student and this row for the fourth student. Okay. So, each row wise I get the information of all students, and column wise if I look in this direction, what do I get? In subject 1, what are the different marks and who have got what marks? And most interesting part is the intersection. Say for example, this element of the array, what will this element tell me? This element is identified by its row and column, which row it is in and which column it is in. This element is 75, and what is the meaning of this 75? 75 is the student 2's marks of subject 2. Okay. It is in whatever we tell you, you can tell that it is a subject to marks of student 2. This is the subject 3 marks of student 3. Okay. So, in that way I can represent any of these as identified by some row name, row number and column number. recall that in the case of one dimensional array, when we are talking of one dimensional array, there we had indices, index, right. So, that index was telling us, say for example, there are, suppose these are marks again out of 10, all right, and I wanted to know what is the marks in subject 1. So, the I value I equal to 0 was pointing me to this. Suppose this is marks. I value was showing this. If I take the I value 1, then I get the marks of this subject, like that. Now, in that case, in the case of one, if I wanted to have this element, that was identified by I value equal to 0, 1, 2, 3, 4. But in the case of a two dimensional array, just as we are seeing here, we will be getting to a particular element again in the same way with index, but here say for example, this element here. How do I identify this element? This element will be identified by this row and this column. So, my index, while this was for one dimensional array, the index was I. In this case, the index will be I and j. So, any pair I j pair will identify which row and which column. So, this particular element is determined by the I value, again just because it is C, I am saying that it is starting from 0, 1, 2 and here 0, 1, 2, 3, 4. So, say this element can be identified by I is equal to 1, 1, right. For example, this element is identified by index value I j, I am sorry here, the index is 1, 1. So, the I j pair is 1, 1. For this, I should be 1 and j should be 3. So, this pair is identified by 1, 3. Whenever I get, so suppose here this array was marks. Similarly, I will have a name for this two dimensional array and I can access any element by these indices. Okay. But in this case, since it is a two dimensional array, I have got two pointers, two parts of this, the row part and the column part. Okay. So, here you can see that the subjects are organized in this way, subject marks are organized in this way and we can access any of these elements using the proper index, the student number and the subject number. The table here in the table that was shown here are showing how many elements? 1, 2, 3, 4, 5 into 4, 20 elements, right. So, the table contains 20 values, 5 in each line and it can be organized as a matrix, two dimensional matrix consisting of 4 rows and 5 columns. Now, C allows us to define such tables by using two dimensional array. What does it mean? The general form is like this: type, array name, row size, column size. Always you compare with what we learned for one dimensional array is just an extension of that. For example, marks 4, 5. So, in this case which we saw just now, it is an array with, and let us call this say the name of this array is also marks, and marks has got So, let me write here, it is marks, and it has got 4 rows and it has got 5 columns. So, that is how I can describe this array, and then we can go on filling up the values of this array. So, array name, row size and column size. So, for example, int marks. Similarly, I can have cells, okay, of 25 items over 12 months maybe. Say I can have something like, so let us try to see what this possibly can mean, is that suppose I have got a table where there are 12 rows, all right. I will have 12 rows here and there will be 25 columns here, all right. That will be 300 items. So, I am not showing that, but say each of these rows may mean, say this is January row, this is a February row, this is a March row, etc. And suppose here there are different items, a shop has got different items, and in that way it has got 25 different items. And here we write how many units of a particular this say shirts, this row is shirts, all right. This one says that in the month of February how many shirts have been sold, and maybe this says in the month of, say this is pen, in the month of January, or in the month of January how many pens have been sold. So, in that way this entire matrix or this array can be named as the array cells, which will have 12 rows and 25 columns. Similarly, and another very important thing to note is this type that we declared also in the case of a one dimensional array is also applicable here, because each of these elements in this array will be of the same type. So, here cells I am saying, and I have said cells is float. So, the way I wrote it is not correct. I should write it as, say how many elements are there, how many, what it can be that in the month of January what is the worth of, not how many shirts were sold, but shirts worth how many rupees were sold. So, it can be here 100.5 say, because each of these elements are floating point numbers, all right. Similarly, matrix can be a 100 by 100 matrix, where each of the elements will be a double precision number. Okay. So, we have got two places, two dimensions that we are specifying here. Unlike what we did in the case of a one dimensional array, where we did something like int marks say 5. So, int marks 5 is a one dimensional array with 5 elements. I can say that these are with 5 columns of this one dimensional array, which is one row. Had there been more rows like this, then immediately I have to identify which row and which column, and if there be 2 such rows, then this array should be described as int marks say here 2 5, okay, because there are 2 rows. Similar to that of one dimensional array, but we use 2 indices. Indices is the plural of index, indices, right. So, The first one indicates the row and the second one indicates the column. Both the indices should be expressions which evaluate to integer values, and that was the case for one dimensional arrays also. So, if I have something like marks 2, 5, these integer these values must be integers. I can write expressions, we will show there later, but those expressions must evaluate to integer values. All right. So, examples are x m n 0. So, whatever m value is, m has to be an integer. Suppose m here is 2 and n is 1, then in this array whose name is x, we have got a number of rows and a number of columns. Which element am I referring to here? I am referring to row 2, 0, 1, 2, 3. So, I am referring to this row, and which column I am referring to? 1. So, this was 0, 1, 2, 3, 4. So, I am referring to this column. Therefore, I am actually pointing at this particular element, all right, this particular element. Similarly, I can do operations like this. What does this mean? Let us try to understand this. This means I am referring to 3 different 2 dimensional arrays. One is A, which has got some rows and columns, and there is another array. This is A, this is B, and I have got another array C. Now, I am taking what is being done here. This means C I K. So, this C is being designated by an index I, another index K. This one is being done by, referred by I and some J. This one by J and K. What is being done here, that for different values of I, J and K, I am selecting, this has got a special application, but I am not going into that. I am looking at taking a particular value from here, that is C I and C K, K is pointing here. So, this one I am taking and adding that with the product of A, I and J, J might be pointing somewhere here. I am taking this element and I am taking maybe B J for B array, J row, I am sorry, J row, J should be here, J row and K column. So, I am taking another element from here. So, I am taking this element multiplied by this element here and adding that with this element, that is taken from C. That is what I am doing. Okay. So, this is a simple example, but this has got a far more reaching implication. You will realize that soon. Here you see what we have done. Here, why is this example shown? Here you see we are specifying the index in the form of an expression. Suppose j was 2. and here which one I am referring to? A j into 2. So, that means A 6 followed by whatever value of k was, might be 6 2. That means, I am referring to the element of the array A. A is an array whose sixth, seventh row and third column element is being taken. So, if this be like this, I am taking the seventh row element and second or third column element, I am taking that value and finding the square root of that, and that is again being put to the corresponding value of, that is coming to some other variable name. Actually, this should be since this is an array, this should have been kept as some other variable name b, might be. All right. So, how is a two dimensional array stored in memory? We know that a one dimensional array is stored in a memory, in the contiguous memory location. So, just for the sake of recalling, if we had if I have a one dimensional array, say 3, 5, 4, 7, they were being mapped to the memory, actual memory. Here is the memory location, the different memory locations, and I am storing them here 3, 5, 4, 7 in contiguous locations. Okay. But what happens to the case of two dimensional array? For example, if I have the array that I am drawing here with 3 rows, 3 rows and 2 columns. All right. So, what is the dimension of this array A? A is 3, 2, okay, 3 rows and 2 columns. Now, suppose it is 1, 7, 5, 3, 2, 0, say those are the values. In that case, if I store it in the memory, I can store it. Now, I am drawing how it can be stored in the memory. I need 1, 2, 3, 4, 5, 6 locations in the memory. So, I will have 6 locations. So, I can store them 1, 5, 2, 7, 3, 0, or I can store them as 1, 7, 5, 3, 2, 0. Now, what is the difference between these two storages? This one is I am storing them column wise. I am storing them column wise, and in this case I am storing them row wise, row after row, right. In C, the compiler stores the arrays row wise, which is often known as in the row major form, and this is the column major form. But in C we are doing it in row major form. There is a specific significance of this, because whenever I want to access an element, say A array, I want to find the particular element, say 2, 3. Which element shall I find out? Here, for example, here let us take this case and let me try to find out the element, say A this is A, capital A, capital A, I want to find out the element 2, 1. That means, I am actually trying to find out the row number 2 and element number 1. So, I am trying to find this one out. Now, where will it be? If I do not know, so say this is accidentally I am coming to the same, let us say, let us make this 1, 1. That means, which one? Row 1, column 1. So, I am actually trying to find this element 3. Now, what is the address of this element? Where is it stored? You can see that 3 has been stored here if I store in the column measure form, but if I store in the row measure form, it is here. So, whenever I am trying to find this element out of this memory representation, I will actually have to fetch it from the memory, right. So, therefore, I have to find out the address of this, and for that I need to know where it is stored, row wise or column wise. Since I know it is row wise, so how should I go about it? Since there are 2 columns, so for the first row I will say that if this be my starting address 1000, then the first row will take 1000 and 1000, this is starting from 1002, all right. This is the first row, this is the second row, and this means the second row part, and second rows, this is 1, what is this element? 5, this is second row and 0th element, and this one is second row and then the next element. So, it is 1, 1. So, knowing that whether it is stored in the row measure form or column measure form is very essential in order that I can find out the address of the element in a 2-dimensional array. We will continue this further. More explanations are required about this.